of ions, electrically charged molecules, between the cathode and the anode. A hot melt glue machine deposits a small amount of glue into the separator, now rolled, and seals the positive end of the paper tube. The glue cools and hardens over the next minute and a half as the consoles move along a conveyor. The next machine injects an electrolyte, a potassium hydroxide solution. It takes 9 minutes to soak through the separator liner into the cathode pellets. Nozzles then inject about 4 grams of zinc gel into the anode cavity. Only about 2/3 of the gel weight is actually zinc. The other third is this company's closely guarded trade secret. It's what makes these batteries rechargeable. The zinc gives the gel its silver gray color. A welding machine fuses 4 centimeter nails onto the cap of the battery. This is where current collects before it's discharged. The machine ejects the cap when finished, and another machine inserts it into the negative end of the battery. This cap includes a safety feature crucial to rechargeable batteries. It can resist high pressure, but if heat or power surges cause excessive pressure, a tiny vent prevents the battery from exploding. The machine folds over the console lip to enclose the contents. A rotating 3-headed crimping machine then makes a ridge in the finished battery to reduce the chance of leakage. An electrical testing machine contacts each battery for 200 milliseconds to ensure it has at least 1.5 volts. These batteries will be ready to use right away. No need to charge them first. The labeling machine uses light sensors to time the labeling of each battery casing. The plastic label lists technical information and adds additional insulation. Then, 3 seconds in an oven at 198 degrees Celsius shrinks the labels to a tight fit. Spain's King Philip II was the first disabled person to get around on wheels. He ruled from a rolling chair with footrests in the 1500s. Today's wheelchairs are widely available, but at a princely sum of anywhere from $2,000 to more than $12,000, depending on the features. This wood, leather, and steel chair is a World War II antique. A modern wheelchair literally runs circles around it. With more than 150 possible design options, today's wheelchair fits the user and the user's lifestyle. The wheel rim is aluminum, the spokes steel. It's much like a bicycle, except for these 6 steel brackets that later fasten to a hand rim for propulsion. Tires are either pneumatic with an inner tube of air, or rigid, just one solid piece of rubber. A machine stretches the tire to fit the wheel rim. Workers install 12 washers, called spacers, along the hand rim. 6 of these 1 centimeter spacers can be removed later to adjust the chair's overall width if necessary. The spacers on the hand rim align with the brackets on the wheel. Workers join them with industrial strength 4 centimeter steel screws. Replacing a wheel and hand rim like this costs more than $100. You buy replacement parts much like you do car parts through specialized dealerships. Bearings make the wheels roll with ease. Installing them is a delicate operation. Workers use special custom tooling to insert the bearings with extreme precision. The tires are rigid and have no treads because they're designed for smooth indoor surfaces. An aluminum crossframe is what enables the chair to fold. They assemble it with 6 or 7 screws per side, depending on the depth needed for the seat, which they'll install later on. The front part of the wheelchair is called the front frame. Workers lubricate the parts so they'll be easier to install. This also enables the wheelchair to fold with ease. They install the rear frame of the wheelchair, then make sure the crossframe folds correctly. Workers test the height adjustment lever for the armrest. Then they install a removable aluminum footrest, setting it to the desired length. It has a heel loop to prevent the user's foot from slipping off. The chair has a foldable sling seat. It's made of nylon and attaches to the frame with 6 screws on both sides. can adjust the armrest height from 20 to 28 centimeters and the tension in the backrest with 3 Velcro straps. The backrest is made of nylon and comes in 9 different heights. Workers insert the wheel axle into the frame, adjusting it to fit with the optional features of the chair, such as a particular style of armrest. The axle has a quick release so you can remove the wheel in seconds. This plastic and aluminum hand lever is a parking brake. It keeps the chair still when transferring to a bed or toilet. This motorized chair has an electrical controller. The user commands it with a joystick. The chair runs on two 12-volt batteries that power up in 8 hours from a household socket. Workers squeeze the inner tube into the rear wheel rim. The air valve slips through, and the front and back parts attach with screws. Now the rear wheel can go onto the motor. They attach the seat and the joystick box, which has on-off and speed control switches. The battery pack provides 85 amps an hour. That's enough power for 16 hours or 40 kilometers. The batteries connect to the charger and controller to power up the wheelchair. A steel bumper and plastic rear hood called a shroud protect the back of the wheelchair from the elements and against minor collisions. This motorized model can glide at a leisurely pace or zoom around at a top speed of 12 kilometers an hour. The transverse flute has been an orchestral instrument since the 1700s. You play it in a horizontal position, blowing across an oval hole in the mouthpiece. The air hits a sharp edge inside, producing sound. You turn that sound into notes by pressing the keys that open and close the flute's holes. They begin production by inserting a solid steel bar into a sterling silver tube. Then using a press, they lengthen it and taper it, reducing the diameter to 1.7 centimeters. This tube is part of what's called a head joint, one of 3 sections that make up the flute. The other sections are the center joint and the foot joint. Next, on another machine, they insert a second tube for the center joint. This device drills small holes to mark the position of each tone hole, the raised rim around each of the flute's holes. Now they insert titanium washers, called spiders, in the holes to help position the tone holes. They place a tone hole around each spider, securing it temporarily with copper wire. Once they solder the tone hole, they'll remove the spider. They solder little posts onto 3 strips of metal called ribs. The ribs and posts will later hold the flute's keys in place. Next, they use what's called a profile cutter to shave the tone holes by minute amounts to perfect the flute's sound. Now, using a wax injector and rubber molds, they create wax duplicates of the 120 different parts that make up the flute's 20 keys. Now they build what's called a tree. Using tweezers and a heated pen, they fuse the wax duplicates to a wax trunk that's 17 to 25 centimeters tall, depending on the type of flute. Then they place the tree in a perforated steel flask covered in masking tape. They pour in a liter of plaster, which hardens around the tree. Then they remove the tape and heat the flask. The wax melts through the holes, leaving plaster cavities in the shape of the key parts. The keys are made from tiny particles of silver or gold. These ones have a reddish hue because of their high copper content. The craftsmen pour a carefully measured amount into the casting machine's upper chamber. The machine heats the metal for 12 minutes. The plaster flask goes into the casting machine's lower chamber. They release molten metal into the cavities. Once the metal cools, they shatter the plaster under cold water, exposing a tree of silver key parts. Using a pneumatic cutter, craftsmen snip off the key parts. They have a dull finish because the silver isn't yet polished. Now they solder the key parts together and polish each finished key with a soft rotating brush. They also solder on a riser, which attaches the mouthpiece's lip plate to the head joint tube. They cut away excess metal from the opening of the lip plate. Then they use a lathe to cut out a hole in the head joint tube. A template ensures they position the hole correctly. Once again, they use copper wire to hold the parts together until soldering. They soldered the lip plate assembly to the head joint tube using a gas and oxygen torch. Next, they mount the keys using tiny wires called straight springs. The spring helps open and close each key over the corresponding tone hole. They test each key's seal, called the pad, for air leaks. A thin strip of plastic slides out if it's improperly sealed. The pad is made up of a plastic washer and a felt cushion surrounded by a synthetic wrapper as thin as tissue paper. A lasts for about 5 years and is very expensive to replace, about $90. It's just one of up to 100 components in a flute, depending on the model. This company's flutes come in silver, gold, and platinum. They range in price from $9,000 to $48,000. Once all the keys are in place, a quick wipe to remove any pesky fingerprints. An engraver inscribes the serial number and company logo. After 120 hours of painstaking work, the flute is ready for its musical debut. Cowboy boots have been kicking around since the 1800s. You can wear them on the ranch or just as a country-style fashion statement. Most cowboy boots are made of cowhide and sell for about $200. For something more exotic, though, how about a pair made of ostrich skin for a mere $500? Production starts with a machine called the clicker that works like a cookie cutter, slicing leather into various sizes of soles from standard to extra wide. The clicker also cuts the other boot parts, such as the shaft, the section above the ankle. This programmable automated stitching machine decorates the shaft with embroidery. The machine works on a dozen boots at a time, using up to 15 different thread colors. Workers steam the shaft to soften up the leather. Synthetics just don't mold to the foot the way animal hides do, so this company uses only the real thing. Python skin, walrus skin, bison skin, even ostrich skin. Cow and pig skin boots make up the bulk of production, though, because they're the most affordable. Workers perforate the shaft, then layer a different colored leather underneath to create a design. This company produces 20 basic patterns, but clients can also order custom designs. They line the shaft with pigskin because it breathes better than a synthetic lining. Workers stitch together the shaft sections, including the underlays, from the inside out. Piping covers the seams. A roller turns the whole thing right side out, flattening the piping for a more comfortable fit. The next machine glues a cotton strip to the leather insole. They'll later attach this strip to the foot section.